512,486 miles. One owner, one engine, never been apart. That's not a forum legend. That's the car Ray drove for 12 years, running a small courier operation out of Phoenix. A 2007 Toyota Camry 2.44-cylinder 2AZ-FE Aisin U250E 5-speed automatic. I met him last summer through a mechanic friend of mine at a shop off the I-10. We spent about 2 hours talking. The first 40 minutes were his maintenance habits. The rest was the story of how a 2AZ-FE crossed the $500,000 mark on the original short block, which, for a V40 Camry with the 4-cylinder, is a real number, but the sort of number one owner in 10,000 actually hits. The other 9,999 rebuild that engine somewhere between 150,000 and 220,000. Now, before anyone types, the 2AZ-FE was famous for stripping head bolts. No way 500K stock in the comments. You're right about the reputation. Toyota issued a warranty extension on it for exactly that reason. Ray's escaped that specific failure because he was one of the owners who caught the early coolant loss, around 130,000 miles, had the block retapped with time inserts as preventive work rather than repair, and kept driving. Which is actually a good preview of habit number 1 at the end of this video. The difference isn't the engine. The difference is 12 specific habits Ray held for 12 straight years without slipping. Not one of them is a secret. You've probably heard most of them before. The problem isn't that people don't know. The problem is that they don't do them, and that a couple of them get repeated on the internet in a form that's not quite right, with a small piece missing or the wrong emphasis. In this video, all 12. For each one, what to do specifically, the mechanical reason it works, and honestly, where the popular version of the advice needs a correction. Because a couple of the most repeated make your car last rules are about 90% myth with a small kernel of truth. One of them I saved for position 2, specifically to unpack rather than list. Counting down from 12 to 1. Habit number 12, the right fuel and the premium myth. Right doesn't mean expensive. Worth saying that up front, because there's a stubborn myth online that premium gas makes a regular engine last longer. On a naturally aspirated engine designed for 87 octane, premium does nothing except cost you more at the pump. Octane above the required rating doesn't improve combustion, doesn't lubricate anything, doesn't extend engine life. Ray's Camry called for 87 in the manual. He put in 87 for 12 years. So what's the actual right then? Right is clean fuel from a source that turns inventory. Gasoline has quality parameters most drivers never think about, and they define what your engine looks like at 300,000 miles. Sulfur content. Tier 3 gasoline standard in the US limits sulfur to 10 parts per million, and the majors hit that. Off-brand or high turnover stations that get supplied from the same terminals as the majors typically hit it too. Small independent stations with slow inventory sometimes don't. Sulfur kills catalytic converters and O2 sensors, and through them, the mixture control loop. Second parameter, deposit control additives. Top-tier fuel is an industry standard developed by BMW, GM, Honda, Toyota, and Volkswagen back in 2004. Requiring detergent levels above what the EPA minimum calls for. The top-tier logo on the pump means the retailer signed on to that standard. Costco, Shell, Chevron, Exxon, BP, most of the majors are top-tier. A lot of independents aren't. Non-top-tier gas will run your engine fine, but over 200,000 miles, you build up intake valve deposits that top-tier avoids. What to do? Pick one or two top-tier stations near where you live and stick with them. Bonus if the station has heavy commercial and truck traffic. High turnover means fresh fuel and cleaner tanks. Once every 60,000 to 80,000 miles, run a bottle of a PEA-based fuel system cleaner through the tank. That's polyether amine, the kind that actually works on intake valves and injectors on a direct injection engine. PIB-based cleaners, which are most of the cheap bottles on the shelf, work in the combustion chamber only and don't reach the intake valves at all. Habit number 11. Never top off past the first click. That first click of the pump handle isn't time to round up to the next dollar. It's stop. Inside the nozzle, there's a vacuum sensor tied to a small tube that draws air from the end of the filler neck. When the fuel level reaches the end of that tube, the vacuum breaks and the pump shuts off automatically. That's the factory overfill protection, and it's there for a reason. Here's what happens when you keep squeezing. Liquid gasoline gets into the EVAP system, the charcoal canister and purge valve, which are designed for vapor, not liquid. Liquid saturates the charcoal canister. The canister loses its ability to hold vapor and starts backventing into the fuel tank. Some months later, a check engine light shows up with code P0455 or P0442, EVAP leak. The shop replaces the purge valve for $220. The code comes back because the real source is the soaked canister in the trunk area. Replacement runs $200 to $600, depending on the car, plus the labor to pull trim to get at it. Second effect. A constantly topped-off tank vents worse in summer heat. Gasoline expands, has nowhere to go, ends up shoved into the EVAP again, and the cycle repeats. What to do? Hear the click? Pull the nozzle. Total is an odd number. That's fine. The couple pennies at the register are not worth an EVAP repair. Habit number 10. Full stop before shifting direction. A simple one that gets skipped constantly on automatics. You pull into a parking spot, the car is still rolling forward at a couple of miles per hour, and you already push the selector into reverse to back out. Small clunk from the transmission. You ignore it. Do it 1,000 times. Physically, what's happening? In a conventional torque converter automatic, forward driving spins the torque converter turbine and a set of clutch packs in one direction. Reverse engages a completely different set of clutches. If the forward momentum hasn't been zeroed out when you engage reverse, two clutch packs are working against each other for a split second. Each of those events tears microscopic friction material off the clutch faces. After 100,000 such events, reverse starts slipping on takeoff. Rebuild on an Aisin U250E is $2,000 to $3,000 on the low end. On a modern Toyota Aisin 8-speed, $3,500 to $5,000. On a CVT, it's worse. Belt or chain on cones. A sudden reversal of load direction is a jolt to the pulley clamping pressure. One occurrence isn't catastrophic. The habit is. What to do? Come to a complete stop. Foot on the brake. Car not moving, then shift. Cost you 1 second at every parking maneuver. Saves the transmission over 1 million cycles. Habit number 9. Parking brake before the selector goes to park. You park on a slope, drop it into P, release the brake pedal. Car rocks forward an inch and stops. What's holding it now is a small piece called the parking pawl, a little metal finger about the size of a thumbnail that engages a toothed ring inside the transmission. In good shape, that pawl can hold several tons. But it's carrying the full weight of the car on a slope, on one small metal contact. Over time, the teeth deform slightly, the pawl bends. Next time you shift from P to drive, there's a hard clunk. That's the stored load releasing off the deformed contact. Over hundreds of these events on hills, the pawl and ring mechanism starts sticking. Selector doesn't come out of P without rocking the car. That means the mechanism is worn and it's time to replace it. On a Toyota, that's about $700 for the parts and labor. On a BMW, it's often $1,500 to $2,000 because the electronic side of the selector is tied in. What to do? Reverse the order you've been using. Come to a full stop with the foot brake. Holding the foot brake, set the parking brake. Only then move the selector to P. Now the pawl isn't carrying any load. The parking brake is holding the car through the rear wheels. When you pull off, drop it into D first, then release the parking brake. Ray's Camry ran 12 years and 500,000 miles without a parking brake cable service, because he never let the transmission carry the weight of the car. Habit number 8. Check the engine mounts. Engine mounts are the rubber and metal blocks that hold the engine and transmission in the chassis. They damp vibrations and locate the assembly. Cheap parts. On a Camry there are 4, and the complete set is $250 to $400 aftermarket, closer to $600 OE, plus a few hours of labor to replace. Here's what happens when they're worn out. The rubber loses elasticity, cracks, and in some cases sheds pieces off the metal core. The engine starts micro-shifting under acceleration. Vibrations that used to be absorbed by rubber now hit the chassis directly, through it into the exhaust flex pipe, the drive shaft, the oil pan. A few thousand miles into that vibration load, you get a crack at the flex pipe weld on the exhaust, a drive shaft hum, an oil pan gasket leak at the front main seal area. All 3 together add up to $1,200 to $2,000 in repairs. How to check? Every 6 months, get under the hood with a flashlight. Look for cracks in the rubber, black streaks of oil where rubber has swum out of its mount, deep deformations. On automatics, additional test. Put it in drive. Hold the brake. Bring the RPM up to about 1,500. The engine physically shifts about an inch under that load. If it's shifting significantly more, one of the mounts has failed. Ford Focus second generation is a classic example. The right-hand engine mount fails first, usually around 90,000 to 110,000 miles. Camry V40 mounts typically make it past 200,000. Habit number 7. Short warm-up instead of long warm-up. 2 competing myths here from opposite directions. First myth. Warm up the engine for 5 to 10 minutes before driving. That was actually correct back when carburetors and manual chokes were a thing. It's been obsolete for close to 30 years. Second, opposite myth. Modern cars don't need any warm-up, just start and drive. That's true in mild weather and on very new engines. But in a January cold snap in Milwaukee or Buffalo, it damages the engine more than a long idle would. The truth is in the middle. When you cold start, the oil is sitting in the pan, not up in the head. The pump takes the first 10 to 15 seconds to route it through the galleries. Lifters bleed up. Cams get their first film of oil. During that window, you can't load the engine. After that, you can drive, but gently, no hard pedals, RPM below 2,500 until the temperature gauge starts approaching the normal range. That's typically the first 3 to 5 miles. Why long idle warm-up hurts? At idle, the engine gets very little airflow cooling, but the mixture in the cylinders is enriched for stable cold running. Excess fuel condenses on the cold cylinder walls, washes off the oil film, and gets past the rings into the crankcase, where it dilutes the oil. By the 15th minute of idle warm-up, fuel in the oil can be a few percent by volume, dropping viscosity and accelerating wear. Standard tribology tests, like the Sequence 8 protocol, are exactly designed to catch this pattern. What to do? Start 30 to 60 seconds at idle, not more. Pull out gently. First 5 miles, easy on the throttle, below 2,500 RPM. No cruise control, no passing, no hard corners. Once the temp gauge is where it wants to be, drive normally. Habit number 6. Change the ATF on real intervals, not on the lifetime myth. Many modern automatics and CVTs list the transmission fluid as lifetime in the manual. That's technically true. It's just that life from the manufacturer's point of view and life from yours are two different numbers. The OEM designs for 100,000 to 150,000 miles. You're driving to 300,000 or more. In their world, the fluid lasted a lifetime. In yours, it died twice. Mechanically, here's what's going on. A TF is loaded with clutch pack friction, torque converter fluid coupling, and sealing hundreds of rubber elements. It heats up, oxidizes, picks up wear particles. By 100,000 miles, the color shifts from clear red to dark red. By 200,000, it's brown with a metallic haze. Black fluid with a burnt smell means clutches have already been running hot and some of the friction material is in the fluid. From there, it's a countdown. What to do? On conventional automatics, ASIN, ZF, older Mercedes 722.6 do a drain and fill every 40,000 to 50,000 miles. That swaps roughly half. A full flush with a machine every 90,000 to 120,000 miles. On CVTs, drain and fill every 25,000 to 35,000 miles. On modern 8 and 10 speeds with thermal management, the process gets more involved because there's an adaptation step. But the principle is the same. There's no such thing as forever. Ray's Camry got 6 drain and fill services over 500,000 miles, staggered as the fluid needed it. The ASIN U250E is still working. One more thing on diagnosis. If the transmission has a dipstick, many older cars still do, and even some newer models hide one under the airbox, pull it and look. 3 things to check. Color. Fresh is bright red. Midlife is dark red. End of life is brown. Smell. Fresh is nearly odorless. Midlife smells like light machine oil. End of life smells like burnt rubber. And that burnt smell means clutches have already overheated and shed material into the fluid. Consistency. Drop a bead onto a paper towel. It should spread evenly with no metallic sparkle. If you can see silver flecks under a lens, that's clutch pack material and steel wear particles. Schedule the change now, not in 5,000 miles. A friend of mine who runs a shop up in Flagstaff made it a habit to show the dipstick to every customer during an oil change. Half of them come back for an ATF service on their own instead of waiting for the shutter on the on-ramp phone call. Habit number 5. Fuel filter on schedule. On most modern gasoline cars, the fuel filter is inside the tank as part of the pump module. Replacing it means dropping the tank, which most shops don't do. Sometimes it's declared lifetime, same set of quotation marks as the ATF. The reality, fuel filters clog predictably. By 100,000 miles, a few tons of gasoline have gone through it, carrying whatever's in the fuel. There's a service life, and it's not infinite. What happens with a clogged filter? The pump works against increased resistance. It heats up more because pump cooling is driven by fuel flowing through it. It's not the tank keeping it cool, it's the fuel moving through the pump housing. Restricted filter, restricted flow, more heat, faster brush and armature wear. The pump dies years earlier than it should. Replacement is $500 to $1,500 depending on the car. What to do? On diesels, the filter changes every 20,000 to 30,000 miles with external access. On gasoline cars with in-tank filters, replace it every 90,000 to 120,000 miles, whether the manual says lifetime or not. Find a shop that will actually do it correctly on a documented schedule. Habit number 4. Brake fluid every 2 to 3 years. DOT3 and DOT4 brake fluid is hygroscopic. It pulls moisture out of the air. Over 2 years of driving, water content reaches around 3% by volume. That's the threshold that matters. Under heavy braking, mountain descents, panic stops, the pads heat the calipers to 400 degrees Fahrenheit and up. Water in the fluid vaporizes into gas bubbles. Gas is compressible. The brake pedal goes to the floor, and the car doesn't stop. Classic brake failure on a long grade. Second effect. Water corrodes the internal aluminum passages in the ABS module. That repair is $500 to $1,200. What to do? Every 2 to 3 years, full fluid flush by the correct sequence for the vehicle. Job takes an hour. Cost is $80 to $150. It's the cheapest safety maintenance on the car. Habit number 3. Terminals, grounds, and connections. Almost nobody talks about this one, and it's absolutely central for a car past year 7. The electrical system runs on nominal 12 volts. Voltage drops of even 1/10 of a volt matter for injector precision, ignition timing, ABS accuracy. Where voltage gets lost, battery terminals, ground straps from the chassis to the engine and transmission, connectors at the crank position sensor and cam position sensor. Over the years, these points get oxide buildup, salt from road treatment, occasional electrolyte residue. Resistance climbs, voltage falls. Symptoms: floating, slow to crank on cold mornings, rough idle that comes and goes, odd codes that clear themselves after a wash, air conditioner compressor cycling erratically. All of that reads as electrical gremlins, but the specific cause is corroded connections. What to do? Once a year, ideally in the fall before winter, pull the battery terminals, wire brush them, apply a terminal grease. Do the same for the main grounds, the negative to chassis strap, the chassis to engine strap, the chassis to transmission strap. Remove them, wire brush both sides. Reinstall with a lock washer and a light coat of dielectric grease. Half an hour of work, a wire brush, and a $6 tube of grease. Ray did this every October. Road salt matters here, specifically for anyone in the Rust Belt or northern climates. Northern Ohio through New England, the Midwest, Rocky Mountain states with heavy winter treatment. The road treatment gets kicked up under the hood as fine spray during winter driving. It settles on every electrical point. One winter's worth on the average ground point puts down enough residue that after 2 or 3 seasons, the resistance has gone up several times over. A spring wash of the engine bay with a proper degreaser and a follow-up shot of contact cleaner on the main sensor connectors is basic prevention. Any decent shop does it as part of a routine service. In a home garage, you can do it for the price of a $10 aerosol can. Habit number 2, the quarter tank rule, and the myth around it. You've heard this one repeated everywhere. Never let the fuel level drop below a quarter tank, because the fuel pump is cooled by the gasoline in the tank, and it'll overheat and fail. Sounds good. It's not quite right. Let's break down what's true and what isn't. The myth part. The fuel pump is not primarily cooled by the level of gasoline sitting in the tank around it. Inside the pump, there's an electric motor with a rotor and brushes surrounded by a housing that constantly has gasoline moving through it, from the pickup screen to the outlet line to the fuel rail. That flow through the pump is what carries heat away from the electrical parts. If you're driving with fuel burn at 25 miles per gallon and the tank is at 15%, the pump is being cooled by the same flow rate as at 80% full. What is true? Over the years, a small layer of sediment accumulates at the bottom of the tank. Condensed water, trace sulfur compounds. On older steel tanks, a little rust. On modern plastic tanks, fine polymer particles from the tank walls. In normal conditions, that layer sits quietly on the bottom. When the fuel level gets low and you take a hard corner or a steep grade, the sloshing and tilting stir the sediment into suspension, and it gets pulled into the pickup screen. The screen clogs, flow through the pump drops, and now the pump does overheat. Not because there wasn't enough fuel to cool it, but because the sediment restricted the flow. What to actually do? Not never below a quarter. Try to avoid habitually driving on the low fuel warning light. Refill somewhere in the 20 to 30% range on average. Once a year you get caught up and drive down to the light, no big deal. If it's your daily pattern, yes, the pump goes out sooner. The distinction matters. The quarter tank cools the pump version pushes people to habitually drive on nearly full tanks, which adds weight, hurts fuel economy, and even wears the suspension slightly on rough roads. The reality is, keep the tank generally healthy, don't habitually run it to fumes, and you're fine. Habit number 1. Pay attention to early signals, not late ones. This isn't a technical habit, it's a mindset. Ray's engine crossed 500,000 miles, not because he ran 12 procedures on a calendar. He ran 12 procedures on a calendar because he was already paying attention. When something changed, a new sound, a new drop of coolant, a slower cold start, he investigated it before it became a repair. Mechanically, the reason this matters. Every serious failure on a car has a progressive stage. Early signs stretch over thousands of miles before the actual death of the component. Early sign of a worn wheel bearing is a thin hum at a specific speed range. Early sign of a dying water pump is a minimal drip on the lower part of the block, invisible without a flashlight from underneath. Early sign of a stretched timing chain is a rare short metal chirp on cold startup that clears in 2 seconds. Each of these can be heard or seen 50,000 to 100,000 miles before the catastrophic failure. Or it can go unheard, and then it's a tow. Ray put it like this: I know my car better than most people know their spouses. It can't tell me when it's off, so I have to listen for it. What to do? Once a week, pop the hood. Look for anything new. A new drip, new dust pattern on a dusty part, which tells you something moved that wasn't moving. New color on a rubber piece. Once a month, get the car on a lift somewhere. Any local shop will do this for $20. Look under. Same idea. Any new spot, new dry patch, new noise from a wheel bearing when you spin it by hand. 5 minutes of attention a week, half an hour a month. 12 habits I listed above. They all sit inside this one. Ray was the second-generation owner of that Camry. He bought it at 40,000 miles from a lady in Scottsdale who'd driven it 2 years and then didn't need it anymore. He put on the other 472,000 himself. Now he's semi-retired, sold the courier operation, and he still has the car in his driveway. He said this at the end of our conversation, and I wrote it down. The car isn't a possession, it's a relationship. One owner listens to it with tools. Another owner listens to a service invoice at month's end. The first one keeps the car longer. That's not poetry. That's literally the difference between 130,000 and 500,000 miles. He said one more thing at the very end. I've had 3 moments in 12 years where I missed the early signal. Each one cost me what 5 normal services would have cost, which means in 12 years I lost the price of a year's preventive maintenance to inattention. Do the math and decide if listening is worth it. If I could leave you with only one of these 12, habit number 1, attention, not a schedule, not perfect fluids, not the right brands. Weekly attention to the car you're driving. All 11 of the others follow from it. Comment below and tell me, which of these 12 do you do without thinking, and which do you always skip? And if you know your own long-lived car, 300,000, 500,000, 800,000 miles, write the make, year, and how it was actually looked after. Those are the stories I use for future videos. If this was useful, like, subscribe, notifications on. I put out a few of these a week. Tools, fuel, diagnostics, and honest DIY without the heroics. Thanks for watching to the end.